In this video, we'll look at the number of protons, neutrons, electrons, and mass number for neon. So as we look on the periodic table, we can see that neon has an atomic number of 10. So the atomic number for neon is 10, and there are different isotopes of neon, but it really doesn't matter. Neon is always going to have an atomic number of 10. The atomic number is also equal to the number of protons. So each isotope of neon will have 10 protons. The number of protons, the atomic number, that's what makes neon neon. If we have a neutral element, and neon's a noble gas, so it's always going to be neutral. If you have a neutral element, like all of the elements on the periodic table, they're all neutral. The number of protons equals the number of electrons. So we have 10 protons, 10 electrons, and that doesn't matter about which isotope of neon we're talking about either. If you're wondering about something that wouldn't be neutral, say for instance you had oxygen, if you just write O, that's considered a neutral element. But if you have a charge like 2- after it, that's an ion, so this isn't neutral. So neon, that's a neutral element. Let's put it right here, Ne. So we're left trying to find the number of neutrons and therefore the mass number. And that's what's going to be different with isotopes. They'll have different neutrons and different mass numbers. And it's not really easy to look at the periodic table and figure out how many isotopes there'll be. That's just something we look up. But often you're given these tables and asked to fill them out. So neon has 3 primary isotopes. So when we have this table, if we're not given neutrons or a mass number, we're going to take the average atomic mass and round that to the nearest whole number. So we're going to round this 20.18 to 20. And if we have that number, now we can figure the neutrons out. We could say the mass number is 20, that equals protons, 10, plus the neutrons, which we don't know. Something plus 10 give us 20. That means we have 10 neutrons. And we would call this neon 20 because of the mass number. That's how we name it. This is the most abundant isotope of neon, something like 90% of neon atoms. If you had a sample of neon, about 90% would be this neon, this isotope here, neon 20. And that makes sense because this is an average of all the isotopes based on their abundance. So 20, fairly close to this. Most of it's going to be 20, but some is going to be heavier. The next isotope of neon we could talk about is neon 21. There's not a lot of this, but there is some in nature. You would find some in a sample of neon. If we have a mass number of 21, something plus 10 gives 21. We have 11 neutrons. We call this neon 21. There's a little bit more of neon 22, where the mass number is 22. And if we want to find the neutrons, mass number minus protons, so 22 minus 10, that would give us 12. So we'd have 12 protons for neon 22. So again, on the periodic table, we have this average atomic mass, which is an average of these masses based on their abundance, based on how much of each isotope there are. And that gives us this decimal. The mass number, that's specific to each type of atom, each isotope. So let's look at neon 20. We can write this another way. It's called nuclear notation. We can put the mass number up here. So here's 20 for neon 20. And we put the atomic number here, which is going to be 10. For neon 21, we could write neon 21, and the atomic number, that's 10 because it's neon. And then neon 22, and put the mass number and 10 again. So this is another way to write the notation just for the specific isotopes, whereas the periodic table, that gives us an average of the mass of each isotope based on how much there is. This is Dr. B with the protons, neutrons, electrons, and mass number for neon. Thanks for watching.